Hi everyone, it's Mr Itzstein here. I'm from Beyond the School Gates, here to do your first tutorial on projectile motion. I'm going to get stuck straight into it. Here's our question. It says a javelin is thrown at 26 meters per second at an angle of 40 degrees to the ground. Ignoring air resistance, calculate the time of flight, maximum height reached, and the horizontal range. So I'm going to start this question by just drawing a diagram. Sometimes these are already drawn for you, but it's always a good way to sort of visualize your problem. So giving us a few key things here, we've got the initial velocity at 26 meters per second. Also got our angle here, 40 degrees to the ground. And I'm just going to draw a couple of dots here just to represent that path of the projectile. Okay, I'm going to annotate as we go. So there's a couple of things that we might need to find here. So there's the time of flight. So that's what we're trying to work out. How long does it take for the projectile to be launched to land at this point? What else do we know at that point? We know that the vertical displacement is going to be 0. And other parts of the question, trying to figure out the maximum height. So that's trying to say, okay, what's the height at this position up here? Okay. Anything else that we need? We're going to need some formulas. So from your formula sheet, look in the projectile motion equations part. I'll refer to them as we go. Other thing is, this is a constant g. We normally say negative 9.8 meters per second squared. So it's normally given as 9.8, but the negative is just denoting that it's going downwards, and all projectiles, things are going to end up downwards eventually. All right, part A, time of flight. Before we actually look at this part, time of flight, I'm actually going to find the initial horizontal, initial vertical velocities, because I know at some stage I'm going to have to use them for A, B, or C. So it's going to be very handy to work them out first. So this is not given in your formula sheet. You have to remember them, okay? So U cosine theta. Cosine is always for the horizontal component. So I'm going to sub in 26 here. Cosine of 40 degrees, and I'm going to use my calculator real quick. 19.9. You can round to sig figures or decimal places. That's up to you, or whoever your teachers taught you. It doesn't matter too much. Okay, so that's the initial horizontal component. Do the vertical as well, which uses U sine theta. So 26 sine 40 degrees. 16.7 for that one. Okay, so these are going to be key. Definitely going to use these at some point throughout solving A, B, or C. Okay. So for the time of flight, need to know t at this time. So what we might want to do is use this equation here. Sy equals uyt plus half gt squared. Okay, we're going to use this equation to find the time because I already know s of y, which is 0 meters. I already know u of y, which I solved before, 16.7. G is given as negative 9.8, so I can sub everything in and solve for t. All right, 0 equals 16.7 t plus half negative 9.8. Don't forget about that. I always throw it in brackets, so you can do that. It's up to you. So this helps me not forget about it. And we're going to solve for t squared. Okay. Just tidy this up a bit, it looks a bit messy. So 0 equals 16.7t minus half of 9.8 is 4.9 t squared. Okay, so it's technically a quadratic with a y-intercept of 0. So you could use your graphics calculator here, or you could just use your null factor law. It's up to you. No bonus marks here, unfortunately. So I'm just going to factorize for t. Okay, so that just means one of these equals 0, and this has to equal 0 as well. Okay, these are our two solutions actually. T equals 0 or if I say all of that equals 0, so it's 4.9t equals 16.7. If I just rearrange that, actually I kind of missed a step there, so I'm just going to quickly show the full working. Okay, so it's 16.7 minus 4.9t equals 0. I'm going to move that to the other side by adding it, so it's 16.7 equals 4.9t, and then rearranging, away you go. So it's 16.7 divided by 4.9 gives you 3.41 seconds if you round it to 2 decimal places. Okay, so we've got two answers here, which kind of makes a lot of sense in our scenario, because the first answer is actually way back here when it was launched, so t equals 0. And the second answer, which we can actually annotate now on our diagram, 3.41. Okay, so that is part A. Generally speaking, we should kind of finish off with a statement. So therefore, the time of flight is 3.41 seconds. Now, like I said before, you don't need to do all this working. You can just use your graphics calculator. And obviously, there's a more efficient method than what I've done here. This focus is all about rearranging equations, so I thought I'd just spend a bit of focus on that as part of the question. Okay, moving on now to part B, maximum height reached. So on the diagram, that's right at this point. Now we need to know a few things before we start solving, and generally speaking, that's going to be the vertical velocity. Okay, the vertical velocity at the maximum height, the projectile is going to get launched. At this position, there's no vertical velocity, so we can say that's equal to 0, and that's going to help us solve. So part B, let's do up here, and this is max height. So I normally say two things: max height, Vy equals 0, or we can say at max height, Vy equals 0. Okay, using one of the equations of motion, Vy equals Uy plus gt. Okay, we can solve for what time that happens, and then we can solve for this thing here, which is the max height. It's called the vertical displacement. Okay, subbing it all in, we're going to get Uy, which is 16.7, and there'll be minus 9.8t. Just quickly rearrange for t, 9.8 on this side, sorry, 16.7, and it'll be 16.7 over 9.8. Okay, so that's about 1.70 seconds if we just round that roughly to 2 decimal places. Okay, so that's a time at that which this occurs, but we need to finish off the question. So Sy equals Uyt plus half gt squared. Okay, we're going to sub in everything now. 16.7 times 1.7 plus half negative 9.8 and 1.7 squared. Using a calculator, about 14.2 meters. So you can annotate this now. Whoops. This is 14.2 meters for that maximum height. And you can finish it off with a little concluding statement too. So therefore, max height is 14.2 meters. All right, last but not least, the horizontal range. So the horizontal range, let's write that down first, is really just this thing here, the horizontal displacement. And there's a nice little formula in your formula sheet that says S of x equals U of x times t. So don't get confused here, don't multiply it by 1.7. We're going to use this one here, which is 3.41, because that is the time of flight for the projectile. Okay, so using U of x, 19.9 multiplied by, where is it, 3.41. 3.41, 67.8. and finish off with a sentence. Therefore, the range is 67.8 meters. Okay, and that's it. We'll go through a more complex question in part 2.